Okay, we're going to continue back with example 7.6. A 25 cm diameter stainless steel ball is removed from the oven at uniform temperature of 300 degrees Celsius. The ball is then subjected to the flow of air at 1 atm pressure and 25 degrees Celsius with a velocity of 3 meters per second. Okay. The surface temperature of the ball eventually drops to 200 degrees Celsius. This statement is very tricky. So determine the average convection heat transfer coefficient during this cooling process and estimate how long the process will take. So, because here it mentioned that the ball eventually drops to 200 degrees Celsius, so we have to find your T surface, the average T surface, to avoid complexity. So 300 plus 200 divided by 2. So your T surface is 250 degrees Celsius. Now you have to find, for sphere, you cannot use T firm, but instead you have to use the T surface, T infinity, 25 degrees Celsius, the properties at T infinity, for all other properties except for dynamic viscosity, you have to use surface temperature. So after you got all the properties, so this is air, so still use the same table like previous example. In table A15, so we are interested to look at T25 degrees Celsius, these properties, and also 250, the dynamic viscosity at 250. Okay. Okay, now, so step 1 is you have to calculate your Reynolds number. Reynolds number is equals to Vd over kinematic viscosity. So 3 ms meter per second multiplied by your diameter 25, so it's 0.25 meter by 1.562 times 10 negative 5 meters squared per second. So your Reynolds number is 4.802 times 10 power 4. This is 4. Okay. Alright. So second step, Nusselt number. So you have to use the Nusselt number, the formula for sphere. So 2 plus 0.4 RE 1 over 2 plus 0.06 RE 2 over 3 multiply by bundle number power 4 mu over S 1 over 5. So plug in all the values and you will get an Nusselt number of 135. So next step, similar as previous, you have to find the H, which is equals to K and U over D. So your K is 0.02551 W per MK multiplied by 135, divide everything by 0.25 meter. So your H is 13.8 W per this. Okay. Once you have your H, you can calculate for your Q. So in Q, first you have to know your area. So your area for sphere, the formula is pi d square. So pi multiplied by 0.25 meter square. So your 0.1963 meter square. Plug in this in your heat transfer. HAT TS minus T infinity. Okay. The surface is 250 degrees Celsius minus 25 degrees Celsius. So, okay, your Q is 6110 watt. So this is the heat transfer of convection. Okay, the second part of this question, it asks for the, let's look back at the question, for the time. How long will the cooling process will take? Okay, to know this, you have to know the energy inside the spherical ball, the initial energy. So it is Q equals to mCp delta T. Delta T is from 300 to 200. So M, you can calculate M from by the relationship of density and volume of the sphere. Okay, so it's equal to density for sphere. The volume formula is 1/6 pi d cube. So d is 0.25. So plug in all the values, you will get 65.9 kg for mass. So once you know your mass, Cp is given. So your Q here, Q, the energy is equals to 65.9 kg multiplied by Cp, which is 480 joule per kg. So your delta T is 300 minus 200. Okay, so your Q here is 3163000 joule. Okay, so your first Q, heat transfer coefficient, this one is in joule per second and this one is in joule. So to get the delta T, so you have to divide your heat transfer of convection by Q energy, Q total. Okay, I'll say this is as Q total. So 610 joule per second. Sorry, my bad. It is actually the other way around. Your Q total divided by Q. I will erase this. It's better to erase this. Okay. Sorry for the mistake. QT delta T is equals to Q. Call this QT and this is Q average. Because we use average surface. Oh, sorry. This one is Q average. Q QT divided by Q average. So he will 316,000 joule divided by 6110 joule per second. So joule cancel out. So you will get that T equal to 15185 second, which is equal to about 1 hour 25 minutes for the ball to cool down from 300 degrees Celsius to 200 degrees Celsius. So this is the final answer for time, and this is for the heat transfer. Okay, so that's all for example 7.6. Your attendance keyword for today is ball. Okay. So you have to key in this keyword ball in the Google Pop quiz. Alright, thank you.